Okay, so if we're looking at this one, the difficulty in this one is the diagram. And then, of course, there's lots of the finding x's and finding y's because there's so many vectors in this question. All right, so we're going to start off with that he sprints 25 meters at 30 degrees west of north, okay, to avoid the large rock that is rolling towards him. Okay, so we're going to have a line that is due north. Okay, as our reference, we're going to go 30 degrees west of that for 25 meters. There's the picture, it's all drawn. Okay, so let's have a look at all the stuff that goes into solving this one. We've already drawn the diagram, that's the hardest part. Okay, we went 25 meters, 30 degrees west of north, then 46 meters, 18 degrees south of west, then 10 meters due south, and then 18 meters, 40 degrees east of north. All right, that contributed to an overall displacement represented by the blue triangle. So if I'm going to calculate all of the x's and y's, this is how I go about it. Okay, red x is the opposite side to the angle that we drew, okay, in that triangle. So I use sine of 30 times 25. So red x comes out to 12.5 meters. Okay, red y is the adjacent side, so I go cos of 30 times 25, okay, and red y comes out to 21.65063509 meters, okay, and that's north, okay, this one is west, okay. Then I do the same thing for the green triangle, right, green x is the adjacent side to this angle. So I go cos of 18 times 46, right? That's going to give me 43.74859.975 meters west. Okay, and then green y is the opposite side, so I went sine of 18 times 46, and I got 14.214.78174 meters, and that's south. Okay, the blue 10 is easy because it's due south. It has no x component because it doesn't go east or west. So the x component for that one is 0, and the y component is 10 meters south. Okay, and then I've got the black triangle here, okay, which is quite small, but black y, okay, ends up being the adjacent side. So cos of 40 times 10 meters, which is 11. Oh, sorry, cos of 40. That should be, yeah, the longer side. I didn't draw it that way, but okay, 13.788799998 meters, and that's north. Okay, and then our black x there is the opposite side, so sine of 40 times 18 gives us 11.57017,697. Okay, meters, and that's east. All right, I had to write down all the decimals this time because I'd never be able to find them all in my calculator again. They would just keep rolling up off the screen. Okay? So now I've got all of those. If I want to find out the overall result, which is the blue D here, okay, then I need to find my resultants x and y. So blue x and blue y. So to find blue x, I need to add all the x's together. I'm going to make east positive, and I'm going to make west negative, and that's what I'm going to do. All right. So in order to get blue x, okay, I'm going to add them all together. Okay, so blue x will be negative 12.5, okay, because it's west, and I'm making west negative, right, plus negative 43.748599975 plus 0, okay, my blue one didn't have anything, right, and then the black x here was 11.57017,697. All right, so I'm getting that blue x is negative 44.678, or 44.678 meters west. Okay?
I got the news.
Now I've got to do all the same things with the y components. I'm going to make north positive, and I'm going to make south negative when I do that. Okay, so I'll have 21.650.63509 plus negative 14.214.781.74 plus our 13 plus negative 10 because we've got the south there, okay, and then plus the 13.788 here, so plus 13.788.79998. All right, so my overall y component is 11.225. Okay, meters, and that's north. Okay, everybody follow what I did there? Okay, where did I lose it?
I got 6.
Okay. All right, but let's just review the numbers. Okay, this y is north, so it's positive. Okay, so when I'm looking at that, there's my first number, 21.650. I made it positive because it was north. Then I had the green triangle where I went south. So I made that negative, and that was 14.21478.174. Okay? Then I had this 10, where I went 10 meters due south. So I also added that on as a negative, because I made south negative. And then I finally added on the y component for my last vector here, the black triangle, which was 13.788, and I made that positive because it was north. All right, everybody with me on that one? Okay, so somewhere along the way, if you didn't get the same answer as me, okay, you made a positive, a negative, or one of your trig calculations may have been wrong, or maybe one of mine was wrong. We'll find out in a minute if I don't get the same answer as either. Okay, everybody follow me there? Okay, so I should have then at this point, as long as I didn't screw up any trig anywhere, I should have the right blue x and blue y to do what next? Right, find the hypotenuse. Find the magnitude of the displacement here. Find d. All right, so to do that, okay, so d will equal the square root of, okay, our 44.678 squared plus our 11.225 squared. Okay, so making the square root of my answer squared plus 44.678. So 44.678.422.78 squared. All right, I'm getting 46.1. So lucky me, I did all my calculations so far correctly. So far. Okay. All right, so I got the right magnitude, 46.1 meters. Now I've got to find this angle, which just involves me taking the two sides that I know are right, okay, and putting them into inverse tan calculation. All right, so to get that theta, I'm going to go theta equals inverse tan of the opposite side, which is going to be the 11.225 divided by the 44.678. 11.2246533 divided by 44.678. 42278. All right, so I'm getting 14.1 degrees, which is what the key had to. Okay, 14.1 degrees, and according to my diagram, that is measured from west going north, so north of west. Okay. Now, obviously, when you have one with that many vectors, is it pretty important to be careful with your calculations?
Yes.
Yeah, because if you mess even one up, it's going to royally screw up everything else. Okay? So we have to double check that. Obviously, all our trig is right. We're making things positive and negative. And guys, that is why on my diagram, as I wrote in all the components, I added on directions to each one. Okay? Always making sure that I would indicate south or north with a positive or negative once I started adding the x's and y's together. Right? It's important to remember all of that stuff. Okay, would you ever get one like this on a unit exam? Hell no, you wouldn't, because it takes way too long to do it. Okay? I wouldn't be able to assess anything else on the test except that one thing. So, okay. However, we did have a quiz yesterday where you had one that would be exactly like I would put on the quiz on the unit exam. Sorry. Okay. One straight vector, one angled vector. Okay. Finding the result. Okay. So that's as tough as they get. Okay. You won't get any more involved than that. But it's always the same steps. Find your x's, find your y's. Okay. Add them up. Do Pythagoras. Do trig. You're done.
Question asked for velocity.
Yes, we're going to get to that in just a second. Okay. So now I have the displacement, okay, which was part A. Okay, find the displacement. Now it says, what's his velocity if this takes 2.5 minutes? All right, so how do I calculate velocity? Displacement over time. So the answer I just calculated is 46.1, okay, divided by 2.5 minutes, which I should probably turn into seconds. All right, so 2.5 minutes should be 150 seconds, right? Okay, so I'm going to say that V equals displacement over time. So that's going to be 46.1 meters at 14.1 degrees north of west, divided by 150 seconds. Okay, that should give me 0.31 meters per second at the same direction. Whenever I calculate velocity, I don't need to do the vector stuff again. Displacement and velocity have to have the same vector. They're talking about the same trip. Right? Okay. Now part C. This is just to throw in there. Do you remember the difference between scalar and vector quantities? What's his speed? All right. What do I need to calculate speed? Distance and time. So the time's still 150 seconds. But now what do I do with all of these vectors? I just add them up. Okay? So to get his total distance, right, is just going to be 25 plus 46 plus 10 plus 18. Okay, that's how far he went, 99 meters. Right, and I divide that by 150 seconds. His speed is 0.66 meters per second. Okay, no vector on that because it's scalar. Okay, I didn't indicate any direction there. I don't have that answer on there, but now you do. 0.66 meters per second. Okay. Is it likely that I might throw a B and a C into a simpler vector addition question? Yes. So don't miss them. Right? There's a real tendency when people are doing questions like this that they get all the vector stuff and they're like, oh, I'm finally done, and they forget about these easy marks that are down below that are just A equals D over T calculations. Right? Always make sure you read the question carefully so you don't miss anything. All right. The other question that we went over on the quiz yesterday was one of those boat questions, okay, where we have to remember they're perpendicular. Okay, read the question carefully so you know whether you're going downstream or whether you're going into the current, ending up going straight across. Okay, those are important things to pay attention to. And okay, I want you guys to try 14 here because it's one of those. Oh no, sorry, it's not. Yeah. We did that one. I don't think we did this one, though. Yeah, we did. Sorry. Okay, I think we actually ended up doing all of those. Okay, so I'm going to make one up here. Okay, and I want you guys to try it. think that's what Okay, you should be writing this one down. Okay, so we got a boat that needs to reach a dock directly across a 75-meter wide river that's flowing east at 2.8 meters per second. The boat's motor, sorry, should be in apostrophe there. Boat's motor can propel the boat at a maximum speed of 4.5 meters per second. Okay, how long does it take to reach the dock? It's going directly across the river, let's say north. Okay, so yeah, crossing from north to south. Question? Okay. Okay, so this one's going to set up as follows. We have our river. Okay, we know that it's 75 meters wide. Okay, we know that it flows downstream or east at 2.8 meters per second. And we know that we're going to wind up going directly across the river. So this is my average velocity here. I don't know what it is yet, but that's what I'm going to end up doing. Right? Because I'm trying to go straight across. If I'm going to go straight across, I can't aim straight across. I need to aim, yeah, this way, into the current a little bit, so that the current will push me back to straight. Okay? I know that this is 4.5 meters per second. That's the maximum speed of the boat. The boat's not going to go that fast. That's the maximum speed of the boat. Okay, but it will end up being a little slower than that because the current will push it back towards straight. This is the number here that I need if I'm going to calculate how long it takes to get across, because it's what I actually do. If I can follow me there. Okay, this V here is parallel to straight across the river. I can't use the 4.5 and the 75 together because they don't point the same way. Okay, to travel this way across the river, okay, is a greater distance than straight across the river. And in the end, I'm not going this way. Right? So I'm going to have to find out what B is in order to do this. Can I use Pythagorean Theorem to do that? Yeah. I can, except I'm not finding the hypotenuse this time. I'm finding A or B. Right? So it's actually going to look like this. That B will be the square root of C squared minus A squared. That's what we essentially have to do here. Right? So we'll have 4.5 squared minus 2.8 squared, and that will give me what B is. Oh, 28. Okay, so we end up going straight across the river at 3.5 meters per second. Where did we go? The beginning. Yeah. Okay, start again. If I want to go straight across the river, which is what the question says, that I need to end up at a point straight across, I can't aim for that point. If I do, I'll end up way down here. With me on that? Okay, so I aim slightly upstream and I max out the boat as fast as it can go. All right, that means I'm trying to do this, but the current is pushing me back, so I only wind up doing this. It slows me down a little bit because I'm pushing into the current a little. Okay, so what I need to find is how fast am I actually going across? Because I know it's not 4.5. Okay, so I use Pythagorean Theorem, but I use it backwards. Okay, since I know the hypotenuse, I look for one of the sides that contributes to it. So instead of going a squared plus b squared equals c squared, I use c squared minus a, and I get the other side. Okay, so I'm basically just manipulating Pythagorean Theorem.
How do you know whether or not you can put the first line diagonal or straight? Like, isn't the one question where it says you can go a certain speed and still water?
Right.
Straight.
Well, no, that would be the speed in still water as well. The reason I know to do this is because the question told me I needed to end up directly across. Okay? If it says you need to go or want to go directly across, you have to aim upstream.
Okay.
Okay?
So what does it say if you're just going to go straight line?
Then it'll say you are heading across.
Oh.
You're not going across. Your heading is across. But the current will push you down. Does that make more sense? So that's how you differentiate. And that's why we're doing so many of these. We have to learn. How do I differentiate between a question like this one where I aim into the current and a question where I aim straight across? Right? The other way to look at it is in the question that's aimed straight across, they're going to say, how far downstream will you end up? That'll be one of the things they ask for. And then you know, oh, yeah, I'm going to end up downstream, so I need to aim straight across. In this one, it says you're going to end up straight across. They don't ask you how far downstream, because you don't. You end up straight across. Okay? Pardon me? I'm not there yet. I started over again because there were questions. So now I'm going to calculate how long it takes to get across. Not yet. I have one more thing to calculate. Actually, two more things, because I didn't finish this calculation. Or I did. It was 3.5, right?
Yeah, but the question was only asking how long it takes.
I know, but in order to get that, I needed to know how fast I was going across. That's why I'm calculating that number. Okay? So, now that I know how fast I'm going across, and I know how far it is across, can I figure out how long it takes to go across?
Yeah.
Yes. Yes. All right, so I'm going to take that 75 meters, and I'm going to divide it by the speed I just calculated. It's going to take 21.3 seconds to get across the river, which is pretty impressive. Okay, for crossing a river. All right, that sort of makes sense. The wording is tricky. Like, was there any hard math in here?
No.
No. You had to do a Pythagorean theorem calculation. You didn't even have to do any trig. Okay, it's all v equals d over t, but it's the wording of the question. So there's like a reading comprehension element. Sorry about that. Okay, in this question. But the reason we do that is because when you get to Physics 30, reading comprehension is critical. There have been, on the diploma exam, situations where they make you read 2 pages of text. And it says right above that text, read the following text and then answer question 40. So you read 2 pages of stuff to answer one question. Right? So reading comprehension is important. That's why we have tricky wording on things like this to kind of get you used to it. Okay? That was a short paragraph, not 2 pages, about a cathode ray tube experiment. Right? And that's kind of the stuff that could come up. Right? Now, as a tip, if you run into a question where it says, read the following passage, then answer these questions, what should you read first? The questions. That way you know what's important in the reading. Okay? I know you got 6 hours to write the student thing now, but you don't want to be in there for 6 hours. Okay? That's the reason you have 6 hours. People don't have test-taking skills anymore. Okay? We're trying to teach you those. If you read the question first, you'd only have to read the passage once instead of 10 times. Okay? So yeah, there's little tips for you. Okay. So next week, okay, this is how next week's going to go. Monday, you're going to get an assignment that you'll be handing in on vector addition. Right, so you'll be working on that on Monday. On Tuesday, we're going to start talking about acceleration. We'll be doing a lab either Wednesday or Thursday on acceleration using the carts that we used for the last one. Right? And then we'll finish off acceleration by the end of the week. and we'll be moving on to projectile motion the week after that. Projectile motion is the last thing in this unit. All right, so you can expect that we will probably have a unit exam in very early October. Right, so before Thanksgiving, just before Thanksgiving, you will have a unit exam in kinematics. Right, I'll still give you 2 weeks notice of when that will be, but I can see it's kind of shaping up that way. Okay, so 2 weeks is not actually going to be all that far off for us here. Okay, depending on how projectile motion and stuff goes.
How many units are?
Yes. Okay, so that's the stuff that's coming up. Now, I would suggest at this point, because there's still about 10 minutes or so in class, okay, I would suggest at this point that you should be looking at the worksheets in the workbook on vector addition and doing any questions that we haven't done yet. Okay? Because on Monday, when you get the assignment, that one is coming in for marks. I will be less helpful when you are answering those questions, because I need to know how well you can do it, as opposed to how well I can tell you how to do it. Okay? One's meaningful, the other isn't. So I would suggest trying a couple more of the questions from that sheet. This is the last day for help from Coder before I have to hand it in to you. Okay? Okay. So have at it.